So we began to deal with two problems. The first problem that is that p of x equals to k equals to a times k times 1 over 3 to k minus 1. The k is 1 from 1 to infinity. First, we need to find the a. What we need to use, the permutation what we need to use is that the sum of probability px k from 1 to infinity is just equals to 1. So what we need to do is just to calculate the sum of the probability. So we can see on the paper, the sum k from 1 to infinity, a times k times 3 to 1 minus k is equals to 1. And it's simplify, we can get 3a times the sums of k from 1 to infinity, k times 1 over 3 to k is just equals to 1, and we let this sum of the part of the sum is equal to s1, so we get a over 3 times s1 is equals to 1. Then we write s1 as 1 over 3 plus 2 times 1 over 3 squared plus 3 times 1 over 3 cubed, and the last term is k times 1 over 3 to k. Then we times 1 over 3 at the both sides of the equation. Then we get 1 over 3 times s1 is equals to 1 over 3 squared plus 2 times 1 over 3 cubed. And the last two terms of this is k minus 1 times 1 over 3 to k plus k times 1 over 3 to k plus 1. Then we get the derivation of k and 1 over 3 to k plus 1. What we get is, if k is nearly equals to infinity, this term is just equal to 0. So minus these two equations, we get 2 over 3 s1 is just equal to 1 over 3 plus 1 over 3 cubed plus 1 over 3 squared plus 1 over 3 cubed plus 1 over 3 to k. And the sum is just, the SE is just equal to 3 over 4. In that case, we get 9 over 4 times a equals to 1. Then a is just equal to 4 over 9. Then we need to calculate the expect of the x. And from the definition, we get this formula, the sum of 4 over 9 times k squared times 1 times 3 to 1 minus k from 1 to infinity. We rewrite this as 4 over 3 times the sum of k squared times 1 over 3 to k, and we let this sum equals to S2, so this is just equal to 4 over 3 S2. Then we write S2 and 1 over 3 S2, and then minus these two equations, we get 2 over 3 S2 is just equal to the sum of 2k minus 1 times 1 over 3 2k. And we also similarly, we let this sum equals to S3. What we get is S2 equals to 3 over 2 times S3. Then similarly, we write S3 and 1 over 3 S3, and take a minus. What we get is 2 over 3 S3 equals to minus 1 over 3 plus 2 times the sum of 1 over 3 to k from 1 to the infinity. And what the answer of this is just equal to 2 over 3, and what we get is S3 equals to 1, then S2 equals to 3 over 2. And we get the expansion of the x is just equals to 2. And the third question is the expect of the x squared. And what we need to do is just similar as the problem B and problem A. we may use the differentiation of the minus of the k cube, and what the k cube minus k minus 1 cube is just equals to 3k squared minus 3k plus 1. And to all these sums together, we get the expect of the x squared is equal to 5.5. The first question is let us to find the probability of k equals to x equals to k under the condition of x between 1 and 10. First, we need to find the distribution function of the x. And from the definition, we can get the capital F x equals to k under the condition of x between 1 and 10 is just equals to capital F x over capital F of 10. And we take a derivation. What we get is just the probability of x equals to k under the condition of x between 10 and 1 is just equals to probability of x equals to k over capital F, and what we get is just for the denominator is 4 over 9 times k times 1 over 3 of k to k minus 1, and the denominator is the sum of probability of t from 1 to 10, and the answer of this sum is nearly equal to 1, so the whole answer is nearly equals to 4 over 9 times k times 1 over 3 to k minus 1, and this is the answer of the first problems. Then we go to the second problems. Second problems, what we need to get first is find and draw capital Fx, f y of y, and capital Fy of y, and the expression of y. First, we know x is uniform in minus 1 to 2. What we get is that f of x is equals to 1 over 3 when x between minus 1 and 2, and the capital of f of x is just equals to 1 over 3 times x plus 1 over 3, and the figure of the capital F of x is just on the paper. Then we calculate the capital Y of the capital F of y. It is just equal to the probability that the capital Y is smaller than y, and this is just equal to the probability that x squared is smaller than y. Also, this is just equal to the probability that x is between minus square root of y and square root of y. This is just equal to the capital Fx of square root of y minus capital Fx of minus square root of y. What we need to point out that is when we let y, when we're in the different regions, the region of x is different. What we said is that, for example, y is between 0 and 1. X is between minus 1 and 1. If y is between 1 and 4, this time x is just between 1 and 2. So then use the formula we get before. We write the capital Fy of y. When y is smaller than 0 or is bigger than 4, when y is smaller than 0, capital F of y is just equals to 0. When y is between 0 and 1, it is just equal to 2 over 3 times square root of y. And when y is between 1 and 4, it is just equal to 1 over 3 times square root of y plus 1 over 3. And when y is bigger than 4, it is just equals to 1. Then we take a derivation of it, we get the density function of y. Yes, this time when y is smaller than 0 or bigger than 4, it is 0. When y is between 0 and 1, we get 1 over 3 times 1 over square root of y. And when y is between 1 and 4, we get 1 over 3 times 1 over square root of y. And the figure is just on the right of the paper. Finally, what we need to do is to calculate the expectation of y. And from the formula, we get two terms of one is from 0 to 1, and another is from 1 to 4. And finally, we get that the expectation of y is just equals to 1. So that is the answer of the second question. And this is all. Thank you very much.